Hello students, today we are going to discuss about the network topology under the chapter networking concept. So before I start with that, I would just like to remind you that we have already studied different types of network in our regular classes, which is LAN, MAN and WAN. So when we talk about the LAN, that is a local area network which is confined to a small building or the organization, MAN which spans the entire city, WAN which spans the entire country or the continent. So when we say about these networks, how exactly the data has been transmitted, how the nodes are being arranged whenever there is a transmission over the network. In order to understand that, we have to study about the network topologies. So the term topology actually refers to the actual appearance or the layout of the network. It actually shows how the nodes are being connected over the network. So today we are going to discuss about the first topology, that is the star topology. This star topology consists of the central node called as the hub or the concentrator. The hub is nothing but it's a kind of network device which helps you to connect the different nodes or the different workstation or the different peripherals over the network. Can you see? Right now we have three nodes. We have one server and we have one printer. That means the hub is a network device which helps you to connect the different kinds of nodes. It might be the workstation, it might be any peripheral device, or it might be any of the computers. Okay, any communication in case of star topology has to pass through the central node known as the hub. Now let us understand the working of the hub. Let us consider this to be as the source. Source is a device which sends the data, and destination is a device which accepts or receives the data. Now what terminology we have to use here whenever we are telling that we are exchange of data? So we have to use the terminologies packet. Now we have already studied in our regular class what is a packet and what it consists of. Packet is a small chunk of a data which consists of the actual data to be sent, and it also consists the source IP address and the destination IP address. Okay, now this source wants to send the packet. I mean to say it wants to send the data. So instead of using data, I'm using the terminology as packet. So this source wants to send a packet to the destination. So when it sends the packet first reaches to its central node known as the hub. So what's the duty of this hub? Hub will send the copy of that packet to this node. It sends a copy of that packet to this node, a copy of that packet to this node, as well a copy of the packet to this node also. So when the packet reaches to this node, it will first identify the IP address which is there in the packet and the IP address of this node. Okay, this node will examine if the IP address of the packet and its own IP address, if it is matches, it accepts the data, otherwise it discards the data. So when the packet comes here, since because this is our destination, the IP address definitely it will match. If so, then this node will accept the data. Now when the packet comes here, IP address doesn't match, hence it discards the packet, and similarly here also it will discard the packet because the IP address doesn't match. And this is how exactly the working of the star topology takes place. Okay, suppose again, now this time on the second time the destination wants to send the data packet to the source. Now whenever this node is replying back to this node, obviously this node will become the source, this will become source for us, and this would become the destination. Whenever this node sends a packet, again it consists of the actual data to be sent and its own IP address as source address and the destination IP address. So when again the packet comes to the hub, all remember any communication takes place, it is being through the central node itself only. So without using the central node, you cannot directly pass any of the data packets to any of the nodes. So when the packets arrive here, again the hub will create a copy and it will send to all the connecting nodes. A copy of that packet will be sent to all the connecting nodes. So when the packet reaches here, okay, so this node will discard the packet because IP address doesn't match. Here when packet reaches, it copies it onto the disk because IP address matches there. Similarly, these two will discard the packet because their IP address doesn't match. Okay, so this is how the working of the star topology. So where exactly this kind of, now let us study about the advantages and the disadvantages of the star topology. The first advantage is ease of service. So this star topology has number of concentration points. Can you see? These are nothing but the concentration point. This concentration point is nothing but it is a point where we are making the connection between the node and the hub. This is nothing but each one dark spots what you are seeing here. These are nothing but the concentration points. That means the connection where I'm making with the node and the hub. Okay, so I have number of concentration points which allows you to provide an easy access of service, and that service can be LAN, WAN or the MAN. And it also help in the reconfiguration of the network. Reconfiguration of the network means enhancing the capacity of my network. Right now it's 5 nodes are being connected. This is what is my capacity of my network. So I can increase. If I want to increase, I need to first to have the unused port I need to have, and then a coaxial cable I need to have. So if these two are available, then obviously I can easily enhance or reconfigure my network. Okay, second, let us see the second advantage, that is one device per connection. That means the failure of single node typically involves disconnecting of one node from the network, otherwise it is fully functional. That means let us consider that this is a faulty node. Okay, this is a faulty node, and let me consider this to be as the source and this to be as the destination. In that case, whenever these two system wants to transmit the data, then there would be no any problem. Though this node is a faulty node, the packet will be easily coming to the hub, and from the hub will pass that same packet to the destination. Obviously the hub has to create a copy, and each copy will be sent to the each and every node that is there onto the network, but still that doesn't stop any kind of communication. So this faulty node, if it is there, we have to disconnect it from the network, otherwise it is fully functional. Then what might be the disadvantages of the star topology? The disadvantages is that if suppose hub fails, if hub fails, we cannot have any kind of transmission of data over the network, isn't it? So that is a major disadvantages in case of the star topology. Next thing is where exactly the star topology is being used. It is extensively used in the data processing and the voice communication. What is voice communication? It is nothing but it actually recognizes the human speech and convert in the form of the packets and then transmit to the different nodes. Whatever the voice communication we will do over the phone or whatever through the internet call or whatever it is, this voice communication, it will identify that human speech, okay, and then convert it into the form of data packets and send it through from source to the destination. And this kind of topology is also helpful in the data processing. Data processing means it is a conversion of your human speech into computer understandable form. Okay, it will convert in the form of computer understandable form and then transmit the data to the respective destination. That is nothing but data processing. Okay, wherever there is a centralized form of communication is required in your network, then we have to go for the star topology. I hope you have clearly understood the working as well as the advantage, disadvantage, and where exactly the star topology is being used. Thank you. Hello students. In this video we are going to study about the bus topology, or which is also called as linear topology. Why it is called linear topology? In the sense that because here the nodes are being serially or linearly arranged. Arrangement you can see here, hence it is also called as linear topology. So in this bus topology, okay, it consists of a single length which is made up of the coaxial cable. This is a transmission medium made up of coaxial cable onto which different several nodes have been connected. Okay, the host at one end, the host or the node at the both are the same. The host at one end of the bus can communicate with the several other nodes which are being attached to its length. That means this sender, let us consider this has to be the sender, this has to be the receiver. Irrespective of the sender and receiver, this sender can communicate to all other nodes which are being connected to onto this cable. Okay, and whenever the transmission takes place, whenever the data transmission takes place, the data can travel along the complete length of this cable, and it can travel in both the directions. You can see the arrow marks here. So the data can travel in both the directions, and the data packet will be received by all other nodes. On identifying the IP address, destination IP address, if it is matching, then that packet will be accepted, otherwise the packet will be discarded. Okay, so let us see the working here. Now let me consider this to be sender and this to be as receiver. Whenever sender sends the data packet, okay, that packet again consists of the data which is to be sent, source address and the destination IP address. So when the packet reaches to its nearest node, first it will identify its IP address, destination IP address and the node IP address doesn't match, hence again the copy of data packet will be moved on to the next nearest node. Again when packet comes to here, again here also your destination IP address with that packet IP address doesn't match, hence the data will be moved on to the next nearest node. Here the match will be found and hence the data packet will be accepted. Now at the meantime, this node wants to send the data packet. Okay, when already one data packet is already moving on to this cable, at the same time this node will try to send, the data will not be sent. It has to wait, okay, until the data transmission is over, until the data packet has been accepted by any other node, that this second node has to wait. That means you can have the transmission only at once. Okay, now what is the use of these terminators? Can you see at the edge we are there? Now suppose think that this is a sender. It sends a data packet where that destination IP address is not there onto this cable. In that case, the data packet keeps on moving because none of the nodes will accept that data. Such kind of unwanted data or the unwanted packets will be absorbed by the terminators. Hence that data packet will be removed from this cable. Unless that data packet is removed, second chance will not be given to any of the node. That means the other nodes has to wait until the transmission ends. Then only they can start their transmission. That is the reason why we need to have the terminators. So this was the working of the bus topology. Now let us understand the advantages of linear topology. The first one is short cable length and simple wiring layout. Here we are using the short cable length, which is made up of the coaxial cable onto which other different nodes are connected. Since we are using the short cable, the maintenance cost will be less and the installation cost will be less. That is why we are having very short cable and the simple wiring layout. Wiring layout in the sense the maintenance. Okay, sometimes it is required in order to have the network. You have to dig the earth and you have to place all those wires. So you need to always maintain to check whether you are getting. If there is a network issues, again you have to dig up and again check the cables and replace the cables. So that is what is wiring layout. That kind of thing is not at all required in case of bus topology because we are using the very short cable. Next one is resilient architecture. That means the shorter the cable we are using, obviously it is very much reliable from the hardware point of view. The less the number of connections, it will be more reliable from the hardware failures, right? It will be more reliable from the hardware failures. The third one is easy to extend. That means additional nodes can be connected to the length of this bus. That means right now it is capacity is 4. I can add still more 4 different nodes I can attach to this cable. But the only thing is I need to have the extra segment. Okay, I need to have an extra cable segment. Plus I also need a device known as the repeater. What is this repeater? It's actually a networking device which will regenerate the strength of your signal. Suppose let us consider this to be as a sender, and 4 more nodes I'll be adding, and the 8th node will be your destination. As the data packet will be sent by the sender onto this length, okay, as the data packet keeps on moving, the strength of that data packet will be decreasing. That means the signal strength will be weakened. If at all, if I have been placed the repeater in between, after 4 nodes, if I place the repeater here, okay, the signal strength will be regenerated and the data packet will reach to the destination without any loss of the data. That is the reason I need to have an extra segment plus a repeater device if I want to extend the strength of this bus topology. You can just see here the repeater. Right, it's a device that is used to regenerate or replicate the signals that are weakened or distorted by the transmission over the long distance. So now as your data packet moves along, come from the long distance, the strength will degrade. Once the strength will degrade, obviously there will be loss of data. Once if it is passed through this repeater, again the strength of your original data will be regenerated. That is the reason why you need to have a repeater. Okay, so these were the advantages. Now let us see the disadvantage of linear topology. The fault diagnosis is difficult. That means the control of the network here, it is not at all centralized. So the detection of the faulty node may have to be performed from many points in the network. That means now let us consider this to be as the sender and this to be as the receiver. When the sender sends the data packets, suppose think that this is my faulty node. Okay, the data packet will never reach to the destination because these have to forward those data packets. Okay, once the here IP address doesn't match, again this node has to pass the data packet to the next. Again this node, if it is not matching, it has to pass to the next. So in that case, the data packet may not at all reach at the receiver level. It may not reach to the receiver. In that case, we will not come to know which is the faulty node. So in that case, I have to examine all the adjacent nodes in order to find out which faulty node. That is why fault diagnosis is difficult. Next is fault isolation is difficult. So once you rectify or once you get to know the defective node is being once the defective node has been found out, it has to be isolated. Isolated, it means it has to be removed from this cable. We have to remove the connection from that node of this node to from the cable. Okay, so that is nothing but the fault isolation. Okay, next one is repeater configuration. Repeater configuration in the sense, obviously if I want to enhance the capacity of my network, obviously I need to add an extra segment plus the repeater configuration, right? Repeater, I have to attach that repeater device to my cable, isn't it? So you have to make the connection again. Yes, you need to remove the connection of this terminator, add an extra segment, add an repeater, then you have to at the end again you have to make the terminator connection. So repeater, this is repeater reconfiguration is necessary. Next one is nodes must be intelligent. As I have said in the working, that until and unless one data packet is there onto this cable, the second data packet cannot come. Otherwise, it may lead to the collision or there might be the loss of data. So, only at once you can have the transmission. If at all, if you have simultaneously, if other node sends the data also, there might be collision or the loss of data. So, to avoid that only, there are the terminators are being placed here. Okay. So, what I was telling here, nodes must be intelligent. So, the nodes, all the nodes have to get the chance to transmit their data. So, the nodes must be quite intelligent in order to decide which node turn is there in order to send the data packets onto this cable. Okay. So, these were the disadvantages of the linear topology. Thank you.